So on problem 3, we're mixing really what look like 3 different types of arithmetic. We've got addition happening here, we've got subtraction happening there, and we also have an exponent. That's connecting a 3 with a 2. So first things first, how do we decide which of these operations we should be worried about before the others? Or which one would you like to do first? Let's do the exponent. So we have to worry about the exponent here first. So the first thing we'll do is evaluate 3 to the power 2. And that gives us how much? 9. Remember, that's not 6. That's a very common source of error when you're working on arithmetic problems, especially when you're working quickly. 3 to the power 2 is not the same as 3 times 2. In fact, it's the same as 3 times 3. And that's something we're going to talk about next when we really dig into exponents and how they work with negative signs, which is going to be another theme that's going to surface here. But anyway, first step, let's get that exponent taken care of. And now there's no parentheses left, there's no exponents left, there's no multiplication or division in this problem left. And so our last end game here is to do addition and subtraction. But then, of course, the question is, since we have both addition and subtraction present, which one of them should I do first? Addition first, always. So let's do addition first. And if I do addition first, 9 plus 6 is going to give me 15. And then I'll do 4 minus 15. And that's going to give me negative 11. Okay. So, all right. So we did addition before subtraction, and we got that answer. But I have a problem with this answer. Why do I have a problem with this answer? I have a problem with this because addition and subtraction are interchangeable. They are the same operation. And for that reason, it doesn't necessarily make sense to privilege one of them over the other. Because if they were the same operation, then I should get the same answer if I did this one first, or if I did that one first. But let's try doing this one over here first, the 4 minus 9. If I do it that way, then 4 minus 9 is going to give me negative 5. Negative 5 plus 6, that's 1. So if addition and subtraction really were the same operation, then I should get the same answer whether I did it one way or whether I did it the other. But that doesn't happen. I get 2 different answers. So here it makes a difference whether we consider that addition always has precedence over subtraction, or whether we try to consider addition and subtraction to always be the same. And this is, again, a common source of error when people work with order of operations type of problems. So how do we resolve this error? We resolve it in the same way that we do when we're thinking about multiplication and division in our viral math problem that we were looking at earlier, right? If we're concerned about multiplication versus division, or addition versus subtraction, remembering that they're interchangeable is the same thing as saying that we can always turn division into multiplication. We can always turn subtraction into addition instead. And so for that reason, sometimes I like to think of the order of operations as having only 4 letters. PEMA. P-E-M-A. Multiplication and then addition. And if there happens to be division, turn it into multiplication. If there happens to be subtraction, turn it into addition. And that way, once we get all the operations written as just one of these, now we don't have to worry. So if I apply that philosophy to this problem, we agreed that 4 minus 9 plus 6 seemed like the right way to start. Let's try and nip that problem in the bud by trading subtraction out for addition instead. So the subtraction sign here in between the 4 and the 9. If I want to trade that out for addition instead, then what is the cost of that? What else do I have to do if I'm going to trade out that subtraction for an addition? Make the 9 negative 9 instead. Right. So this is nothing more than the addition-subtraction version of keep, change, flip. When we traded division for multiplication, when we were talking about fractions last week, when we flip the sign, we when we change the sign, we flip the number that came after the sign by turning it upside down, by turning it into its reciprocal. Why? Because a reciprocal is the multiplicative inverse, right? It does the opposite of what multiplication does. So when I apply keep, change, flip to an addition problem, when I trade subtraction for addition, the kind of flipping that I do is not a flipping upside down, but it's a flipping of positives for negatives. Right? It's the same thing when we're subtracting a negative number. When we subtract a negative, it's the same as adding the positive, because that positive is the opposite. It's the flip of the negative. Right? So if I trade out this 9 for a negative 9, now I can write this whole expression using only addition symbols. And this is the number one best way to avoid making the error of always giving addition precedence over subtraction, even though addition and subtraction are interchangeable. All we'll do is interchange them. Change everything out for addition. Put everything on the same footing. And once everything's on the same footing, now addition, like multiplication, has that property of associativity, for which it doesn't matter if I add these two numbers first or if I add those two numbers first. I'm going to get the same answer either way. And this we can check also if you want to. If I add 4 plus negative 9 first, I'm going to get negative 5, and then add 6. That gives us that answer 1 that we had before. What would happen if instead I decided to add the negative 9 plus 6 part? Negative 9 plus 6 is going to give me negative 3. And then I'd have 4 plus negative 3, and that's going to give me, oh look, 1. So now we have some reassurance that we must be on the right track. Right? Because once we trade out subtraction for addition everywhere that it appears, it doesn't matter which of the additions we do first. Just like when we traded division for multiplication, it didn't matter which multiplications we did first. And in these cases, often people will just remind themselves by saying, once all the operations are the same, we lose nothing in just going from left to right. So that tends to be the way that once everything is written with the same operation, people will navigate these problems. So when I'm looking at this through my lens of expertise, having, my job is thinking about these kinds of problems and how to talk about these problems with people like yourselves, that I'll typically just remind myself, go from left to right, 4 plus negative 9, and then add 6, and then get the answer. But the good news is it doesn't matter at that point. We could have gone from right to left, and we would still end up with the same answer. That's how I know this is a good strategy.